Here we've got the questions that are at the end of the first specific heat capacity PowerPoint, where you're really just comparing different values of specific heat capacity for different materials. So you were answering your 5 questions based on this table on the right hand side. We're going to go through them one at a time. So what you can see on the right hand side, I was picking out the different liquid materials. It should be quite clear just from looking at the values that you're given in the table. The numbers are higher, so the liquids have much higher specific heat capacities than the solids. You can just do that by comparing it on the table. Number 2, we're looking for which metallic solid has the greatest specific heat capacity. So here I've picked out the metallic solids. Please excuse the dodgy handwriting. And aluminium, you can see at 900 joules per kilogram per degree Celsius has the highest specific heat capacity of the metallic solids. Question 3. Which requires more heat energy to raise its temperature by 1 degree Celsius? 1 kilogram of steel or 1 kilogram of glass? So I've identified where glass and steel are in the table. You can see that glass has a specific heat capacity of 700 joules per kilogram per degree Celsius compared to steel, which is only 490 joules per kilogram per degree Celsius. This means that glass needs 210 joules more energy to raise its temperature by 1 degree than steel would. So more heat energy, because that specific heat capacity is higher, more heat energy is required by the glass than by the steel. Question 4, which requires more heat energy to raise its temperature, granite or concrete? So if you look in the table, you can see the values there. We notice, we've been tricked. It's a trick question. They both have the same value for specific heat capacity. So this means they both require the same amount of energy to raise 1 kilogram of their mass's temperature by 1 degree Celsius. And finally, question 5, which gives out more heat energy when it cools down by 1 degree Celsius? 1 kilogram of aluminium or 1 kilogram of copper? This is a really interesting question. You can see that aluminium has a higher specific heat capacity. So far we've talked about that meaning that it needs to take in more heat energy to increase its temperature by 1 degree. But this same process works in reverse. So as it cools down and its temperature drops by 1 degree Celsius, it's going to give out that energy, the same amount of energy that it had to take in. So because aluminium had to take in more energy to increase its temperature, it will give that same energy back out. So it will give out more heat energy when it cools down by 1 degree compared to copper in this instance. I've got the new formula here. So if you're measuring the heat energy given to a substance, that's EH. C is your specific heat capacity. So that is the number that specifically describes for the material that you're looking at how much energy is required to raise its temperature. So that number is specific to the material. M is your mass. In physics, we always use kilograms. If you do chemistry, you may come across this formula in chemistry, and sometimes you'll use grams, and that's fine for chemistry, but in physics, please make sure that you're using kilograms at all times. And then you've got that funny triangle in the T. The funny triangle just means change in. It's sometimes called delta. So delta T is change in temperature. That's a capital T for temperature there as well. So the heat energy that's required would be your specific heat capacity multiplied by the mass, multiplied by the change in temperature, and you'll be delighted to know that in the next lesson we're going to be looking at some calculations for these. There was a little example calculation at the end of that PowerPoint, so it might be worth taking a moment to look over that as well, because we will at points be rearranging this. And I'll go over that with you in the next video. Alright, thank you.